First of all, just wanted to say that I'm really happy to join the conference today. It's actually the second year in a row, and I'm always happy to join the conference. I enjoy how the organizers set everything up to various conferences that they do. So definitely recommend to stay tuned and look for the next events because it's always such a pleasure for me. So some of you maybe know that I do a set of talks about Alice Adventures. Maybe you saw those on the previous conferences, and it's kind of a story aside of just a technical talk. So this time we are going to travel back in time to the past, and we'll discover what kind of tools we can use for that, and also we'll follow Alice along the story. So I work as big data developer at Captify. Actually, Captify is a crush partner of the conference, and they present multiple jobs that we have right now for big data developer as well. So if you're interested in tech stack, everything around that, what we do in terms of the product, because the product is amazing. I've been working here for 2.5 years and really enjoy that. And also a lot of great things aside from the tech side, for example, there is a diversity inclusion program, and I'm ambassador at Kiev office, and all of the other great initiatives on mental health and everything around that. Also, I'm Women Who Code Kiev data engineering lead, and I often speak at conferences and meetups. So first of all, we are going to get back to the previous episodes or talks that I did on Alice, because we have this general story which continues from one talk to another. So I always try to do this short recap to understand where Alice is now in terms of the story. And also it helps to understand what she learns along the way in terms of tech stack, in terms of the world she travels to, and also helps to understand what kind of challenges she has now and what kind of mysteries she needs to discover. So in her first adventure, Alice traveled to the world of pods and high order functions. In the functional forest, she met the monads and the high order functions. Also, she met the pods there. And during this trip, she discovered this part of the world, which is more on the functional side and more on the Kubernetes side, which is called default namespace city. And she discovered that actually some of the concepts from functional programming help to understand Kubernetes better and vice versa. And that's how she discovered that there is this kind of strong link between these worlds. And during this adventure, she learned how to create various objects in Kubernetes, and she created Magic Database or Magic DB, which contained her knowledge about this world. But she didn't want to just let go of this adventure, so she decided to take this knowledge with her in the form of this kind of safe lock, which in Kubernetes terms is a persistent volume. And the pod from this Magic DB cluster tagged along with her back to her human world. On her next adventure, we skipped to 2 years later, and Alice became a Scala developer. And she just went on vacation, and in the forest, she found this cave where she discovered this safe lock, which she totally forgot over these 2 years, and the pod who was just living all these years in the forest and had a longing to get back home to his family. So Alice decided to kind of discover what it is in this persistent volume, which brought back her memories of this adventure. And also she had this responsibility to find a way to get back the pod. This time, as Alice became a Scala developer and she already knew that there should be a way to connect Scala and Kubernetes, she learned how to create objects in Kubernetes using Scala, using Scala libraries, and she discovered different types of libraries that there are there and stuck with one of them. And eventually she built a rocket or a launcher which helped to save the pod and get him back home. And on the next adventure, 3 months later, she was working as a big data developer, which became her new interest. And during this time, she helped data science team to deploy machine learning model using Kubeflow, again, using her knowledge of Scala, using her knowledge of Kubernetes. and her new interest of trying to understand how machine learning models work from the side of big data developer, she was able to build this model for entities recognition. So the essence was to figure out each word in a phrase or sentence. For example, like weather in London today, and here is the entities are natural phenomenon, some word, which is utility one, geographical entity, and time indicator. And why was that important is during the testing, she got this mysterious message that plots and higher order functions are in danger. And then 4 days passed, and she traveled to the mysterious world where she met the caterpillar and the Mad Hatter, and she needed to solve the riddle to figure out how she got there, how she can save the plots and higher order functions. And the riddle was what was lost can be found only in the anomalies of this world. So eventually, the Mad Hatter, more from the perspective of data scientists or machine learning engineer, built anomalies detection model, and Alice helped to set up the data processing pipeline and deploy the model using Kubernetes via Spark job. And the result was a bit weird, but then when Alice tried to decode it, she woke up and figured out that she actually fell asleep. And she was holding a note in her hand saying that the past is the key to the future. So that's where we are right now. Alice woke up and got this mysterious note, and 1 day later, she kept thinking what exactly it meant and how she could kind of get back to the past or get some understanding of what happened to the world of plots and higher order functions. And she didn't even know how to get a reference to it. So she kept thinking who actually gave her this note, or she traveled to that world in reality and she kept the knowledge from it by decoding the note itself. So she had this suspicion that maybe someone was actually trying to help her or someone was kind of reaching out from that world. But anyhow, the only link that she had right now was this safe lock or persistent volume that contained information about the world in the form of MagicDB. So she decided that she just needs to take a look through this data and see what's happening in there and maybe traverse the data. Maybe there is some kind of history or linkage to that world. So Alice just connected it to the system, connected the MagicDB, and now she could look through all of the data and figure out what exactly is happening there. And what she saw was actually this structure, what we in big data world call partitioning, when the data is divided into specific categories. In this case, we have dates and hours. So here she saw that the first date was actually, for some reason, 2014, June 8th, while the next ones were going back to the yesterday. So she realized that there was some kind of recording of information about this world in terms of the dates and even divided into hourly basis, which meant that there was some history behind it, and she could actually research it and understand what happened during the time she was in that world and during the time that she kind of get back and forgot about it. And she saw that actually it's not only about just traversing the data. That would be way too complicated, especially if you don't know what to look at. While she could just look into data versions. And there are actually tools that allow to look into versions of the data, discover them, manipulate those versions as well. And in such a way, it's possible to kind of travel back in time and look into the past versions of the data. And Apache Delta Lake as an open source tool is one of such tools. It was built quite recently, a few years ago, and Alice already heard about it and kind of tried it a bit, but didn't really see the case for usage yet. But that's why she actually remembered about it, because it had so many features, including one very important for her case here. So Alice doesn't really like to work with some tools without getting a better understanding how it works behind the scenes. So in terms of Delta Lake, if we would represent it in a more abstract way, it looks like this. We have some kind of cloud storage, for example, AWS, and we have this storage layer on top of this cloud storage, which is in this case a Delta Lake, and then Apache Spark service above all of that. So basically, we don't embed any additional functionality into Spark, or we don't build anything on top of Spark. And this additional storage layer allows to actually manipulate the data in various ways that we need. Specifically, the data is stored in so-called Delta format, and also we are able to manipulate the metadata around it. In this case, metadata would be the actual recording of the versions of the data. And so it would look like this. We have Apache Spark job that writes some data to storage layer. The data is stored in data files, for example, partitioned by dates or hours or both. And alongside these data files, we have a directory with a bunch of metadata files. And they all have specific namings, and most of the cases they are stored in JSON format, which is like a system format for Delta Lake, and data files are usually stored in Parquet format. So how it works in terms of the bigger systems, there is a cloud storage, for example, AWS, Hadoop, Azure, and others. We can write data of different formats, streaming data processing, batch data processing, and in the end, we get so-called ingestion tables. Tables in this case are not actually relational one. We are more talking about the structure of the data. We call them tables because that's the concept within Delta Lake when we refer to our data as files to tables. So we have some ingestion or raw files that we get, usually not processed. We just read them from the storage system. Then we build some additional transformations. We can divide this data into more entities, for example. And this is another layer with so-called refined tables. And after that, we can build some additional aggregation on top of that. And in this case, it's going to be the next layer with aggregated data store. Another interesting feature about Delta Lake in comparison to Spark and why it's kind of this additional layer to the functionality that there is in Spark is the concept of asset. So it's used a lot in databases when we are talking about transactional nature, but that's not something that we can apply to data transformation frameworks, basically. So it's not something that would work for Spark. And I can explain that using these kind of concepts within the asset concept. So first of all, there is atomicity, and in databases, when we build some kind of query, for example, creating or updating the data, we expect that this action or transaction is atomic, which means that there won't be any external issues around that. For example, crash of the system, or that when we create it, that we have some expected result around it. While in Spark, we don't always actually can assure that, because our Spark jobs are distributed, and sometimes there are some concurrent jobs running, or some executors can get into this competition. And therefore, we don't always can assure that our actually transactions or any actions are atomic. The next concept is consistency, and it means that the data in the system is in some expected consistent state. So when we write some new records, before this action, the system is in one state, and after this action, we have, for example, two more records. That's on the side of consistency. Why it doesn't work in Spark is because as I mentioned before, some crashes can happen during the job. We can not only remove some data, we can overwrite something accidentally. For example, if we set up the override and for some reason the job decided to kind of delete everything and save some new format, or on the contrary, delete everything, and not save anything because some failure happened during the job. So as a result, we don't have any data, for example, no history. And it means that Spark is not very consistent on that side of things. Another concept is isolation. It's about the fact that we don't have external factors outside of our transactions. And as I mentioned already in Spark, we don't have this assurance. And durability, that over the time, some changes will be like persistent and preserved, while it's not always the case with Spark again. So the fact that Spark doesn't actually abide to these rules doesn't mean that it kind of lacks something, that it's a disadvantage. It's more in terms of the nature of the tool. We don't expect Spark to have it, but via Delta Lake, we kind of add this additional layer, which helps us to extend the functionality and kind of have more, basically. So again, talking about transactional issues, as I mentioned that there can be failures during the write, and we can lose all our data, or we can lose just historical data. And another important thing of Spark in comparison to Delta Lake, we can have issues during data updates. So basically, when we overwrite something, or the fact that we can change anything in the data, for example, reprocess it, and we won't have any recording in our system that it happened. In the future, it would be harder to figure out what actually triggered some failure because we don't know if any update happened in the past. Or sometimes we don't even know which update triggered this failure because it happened like a few months ago. So it's a bit hard to trace sometimes the history of the data changes without being able to have this kind of metadata alongside it. So Delta Lake has this feature of asset transactions. Also, it has a feature of schema enforcement. So in Spark, it's from case to case. In a lot of cases, big data developers try to enforce schema because it adds more to kind of having an expectations of what kind of data we see. And also helps with the system. For example, when you try to build some concepts like data mesh or something alongside that, and we want to have specific schema on each step of the data processing in different side of things. For example, for ingestion, for refined data, as I shown before, for aggregated data. In this case, it's very important to have enforced schema. And Delta Lake supports actually enforced schema. Another very important feature for Delta Lake is metadata handling. As I mentioned, Spark itself doesn't really track the history of changes, while Delta Lake allows to save this metadata as separate files. Actually, it's also scalable, so over time, all of the metadata is also stored in the system, and Delta Lake allows to reference older versions. And it's kind of similar in that nature to Spark, the way that we have scalable data storage with Spark. With Delta Lake, we have scalable metadata storage. Another feature is around upserts and deletes. As I mentioned, that it's not very consistent in Spark. In Delta Lake, it's easier. Every inserts or upserts and deletes are tracked, and they create usually different versions of the data. So we can get back to some version and figure out that actually something was deleted, and therefore now we have a new version. And the most probably interesting feature is time travel, which allows to kind of travel back in time in terms of the data and see what happened before, what other versions that we had, how the data changed during these versions, and how it can actually, and we can create new versions alongside that and kind of roll back to them and manage those versions in different ways. So Alice was interested the most in this feature because that was basically exactly what she needed. She wanted to look into this data and figure out what happened before and look into the current state as well and kind of compare the state of the data. So what she had aside from the data is this folder with metadata, similar to the structure that was described before, with data files and metadata files alongside it. So She actually saw that this is interesting that she already has metadata files available. Also, one more mysterious question, whether someone kind of helped her up with setting up this structure or somehow it was stored this way from the beginning. So the metadata looks like this. There is a set of JSON files with numbering. These names are auto-generated. And the last checkpoint, which is like current version or the latest version usually. So in order to set up the Delta Lake, Alice just needed to set up library dependencies with Delta core, some version, and also she wanted to manipulate the data by not only like looking into it, but probably writing as well. So she added these two configurations, like Delta Spark session extension, and added Delta catalog as a Spark catalog as well. And she set it up all in Spark session. So what Delta Lake allows to do is to load the data in the form of the table. So she just read the data of Delta format from the location, which is MetaDB. And what she got is this table of structure having columns like timestamp, which specifies probably the date of creation. Entity name can be like random name or set up by the system. Entity type, in this case, a pod, and entity it belongs to. So in Kubernetes, we have more simpler entities like pods and more complicated ones, which consist of more simple ones like hierarchy. So stateful set consists of these three pods. So she figured out that actually it's a recording of the objects in Kubernetes world with the timestamps when they were created, with their names, the types of these entities, and the entities they belong to. But just looking into this data is also doesn't really make sense because there are a lot of entities, different types of those. She was more interested in the changes of this data. And she was kind of happy that she can look directly into the history and see, for example, how the number of objects changed over time, see what events happened that triggered these changes, and figure out what's happening right now. So there is this function called history, which should be called on Delta table. Delta table being a specific class of Delta Lake library. So just calling like for pass with Spark session and the name of the table allows to call history on that. And history has a recording of all of the versions. So in this case, we have versions starting from 1, 2, and so on. Again, starting from the date 2014. And what she saw that there was some mysterious user as an architect, which had some first operations of create. So she decided to look into this whole history and figure out what happened step by step over time. So the first event was world creation. Someone created this like history ledger or a book which would have this history about the world. And someone, probably the architect, just set up this world to be created. And the next step was the creation of default namespace city, which was the city where the pods lived. Also, mysteriously, she didn't really know at the time how it was created before the factory, because the factory was created next. And during her adventure in the world of pods and hierarchy functions, she was at the factory where she saw how new objects are created there, how they're updated when needed or deleted when needed, and she created some objects herself there. So now, like, the factory was set up, but it was like way before she even visited the world. And then there was this weird event of discovery of the forest by the pods, and it was weird because she didn't really see any information about the functional forest in the database. So it meant that probably it was more of the database of Kubernetes world because at some point they just discovered the forest and probably built this link and a bridge between these two worlds. And then she saw that there was this important event, which was actually her first visit to the world of pods and hierarchy functions. And she was curious whether this event actually influenced something aside of just new objects that she created. And indeed, the next version was around the pod getting lost. And that's exactly what happened. MagicDB cluster pod like tagged along with her, and therefore it caused an error in the system, the fact that one pod was missing from the cluster. So Alice decided to look into a specific version and see how it looks like in terms of the amount of pods there. So here we have version number 5. So the previous one was version number 4. In order to look into the version, we need to read the data in the format delta, set up the number of version, in this case it's number 4, and then load it from the table. Here Alice added additional filter to check only the pods and just count the number of the pods at the time that she visited the world. So the result was 10,400 along with the pods that she created. So she decided to do the same thing for the next version and check whether in reality the error of the lost pod actually influenced the number of the pods in the general system. And indeed, there was like less pods now, like basically one pod getting missing. So she thought that actually she helped the pod to get back to the world and probably that could fix the issue, but she was still curious what happened after that. And what she saw kind of really surprised her because the next version of the data showed that probably that failure of the pod triggered a lot of pods getting lost for some reason, which meant that like objects of higher entities like stateful sets or deployments couldn't find their pods. And she didn't really know whether it was a system failure or a failure in terms of actual pods like physically being missing from this world. So she decided to check actually how many pods did that influence, which is just the same request that she did for versions number 4 and 5. But this time, this is version number 6, where we have a lot of lost pods. And the result was really surprising for Alice because we see now that there are 6,000 pods before we had 10,000, which means that around 4,000 pods got missing. And Alice was wondering what actually happened to them. Did someone influence that, or did that failure with the lost pod actually influence that? And while she was wondering, she looked into the data, and at the same time, the next version was mysterious visit of the second human. And she obviously knew that it wasn't her, so she was thinking who exactly actually visited that world and whether this person tried to help them or actually kind of influenced what happened with the lost pods. But the next event actually made her really sad because there was some factory failure and she was not sure whether this failure was around lost pods again, like system failure, or someone tried to destroy this factory because there were no recordings of that visit by some mysterious human at that time. So Alice thought that probably that was her fault. Like she has made a mistake when she decided to steal this database and the pod, and it could trigger a set of these failures and probably triggered the failure of the factory itself. So Alice was very sad about it, and she kind of blamed herself. But she had this small hope that maybe there was some mysterious visitor who was the cause of that, which also was not really reassuring, but at the same time, it's kind of made her feel a little bit better and not to blame herself. At the same time, she was thinking that maybe this mysterious visitor actually tried to help this world, and the important question was to figure out who that person was and what actually happened next. But before that, Alice felt like she needed some time, and even like sitting at her favorite cafe and eating her favorite cheesecake didn't really help her. She was thinking that although she is not sure that these events are fraud, someone did try to reach out to her, and it meant that she had some chance to help the pods and higher order functions, probably something that she can do to actually save them. And she already felt responsibility for them because she kind of did a lot of mistakes during that adventure and was a bit reckless when she stole this pod and the database. So Ellie's idea was pretty simple and kind of reckless in a way, is to just try to write back some parts to the database and see whether it would work on the system level. So in order to write the data, it's just a similar way we would do in Spark, either creating a file or creating a Spark data frame directly. So Alice didn't really want to write like a lot of pods. She just wanted to test it on a smaller set of those. And in this case, she decided to write the pods of her MagicDB CRD, or custom resource definition, that she created. And those were called like MagicDB 012. So she set up the same format as there was in the table to fill in all of the columns with timestamp, entity name, type, and the fact that they belong to CRD. So now it looks as a Spark data frame. But in order to write it out, we just have to use the same thing as we did in Spark, just writing the data, but specifying the mode, which would be like appending the data, saving to the specific path of the table, and the format should be delta. And then Alice could read this data with the same format, delta, and filter out the pods by ordering them with a timestamp and figuring out whether edit pods are in the system now. And indeed, she could see in terms of the structure that the most recent pods were like MagicDB 012 that she added. They filled in the structure perfectly, so it worked well. But she still didn't have kind of this guarantee that the pods were created in the system itself. And she didn't really know whether there was a way to figure it out. So she decided to play a bit with kind of deleting some unnecessary data. So she thought that maybe she could just delete kind of these pods just in case, and then try to write more pods there, or just look more into the history and then try to recreate some of those. And there is this function called vacuum on delta table, which allows to delete the recent data. But the issue with vacuum, which Alice didn't thought of, was the fact that the parameter to the vacuum function doesn't remove the latest hours, but on the contrary, it works in such a way that it preserves the latest hours. So basically setting a 3 there means that all of the data would be deleted until the 3 recent hours, which was definitely not what Alice expected. So Alice luckily noticed that and didn't run the function, but she felt like she could make kind of a bigger mistake on this case by removing all of the data and information that she had about this world. So she decided to look how actually her events looks like in the system, whether they create new versions. And indeed, the same history function showed her that her operation create with the command new pods created added new version to the data, but she was not sure whether it actually influenced something. But then there was some mysterious event which happened like right after it. And this event was all pods got lost. So Alice was shocked that it happened right after she tried to do something and save them. And also, it was really hard to understand on her side now whether the fact that she tried to kind of work with this system caused this failure, or that there was actually something happening at the same time in that world. And at that time, like all pods just got lost. So she still decided to check whether there's indeed no pods there. And the result was as she expected. Indeed, there were like no pods left in this version of the data, which was very sad for Alice because she felt like kind of losing her friends and she didn't really know what happened to them. But then she thought that there was some interesting point about the fact that there was nothing about the functional forest. She only saw some information about functional forest discovery in the beginning. So there was this small hope that maybe the functional forest part of the world was intact, and maybe functional objects helped the pod somehow to escape, which was kind of a possibility, because if they are missing for their world, maybe they are in the functional forest. But she didn't really know yet what they were running from, and Alice was keen to discover that. So she decided to test her theory and just look through the data and figure out whether there were actually only Kubernetes types of objects in this system. So in order to do that, she chose version number 4, being kind of the most stable version when the forest is already discovered, and a lot of Kubernetes objects existed in the system. And she selected only entity types column just to check on the entities. And here she saw like a long list of entities, pods, replica sites, deployments, CRDs, but all of those entities belong to Kubernetes. So it meant that indeed there was no recording of the functional forest entities in the database, which kind of added to this hope of being able to find her friends in the functional forest, or probably being helped by the functional forest dwellers. And also Alice thought there is one more theory, maybe actually this mysterious architect who created the world, who kind of created all of the objects, could help her, and it would make sense to figure out who this architect was. And maybe she could even help to recreate the world herself, now learning about Kubernetes and functional programming so much, and being able to do a lot of things. So Alice thought that out of all of this information that she gathered, now knowing that all the pods are lost, there is no information about functional forest, which means that maybe it's safe now, and not knowing what exactly is happening in this world from the distance, she wasn't sure actually when some things happened, whether it's kind of happening like right now or some events happened in the past. But she knew for sure that she needs to find a way to help them and apply her knowledge and save her friends. And the only actual idea that came to her that she needs to get back to the world of pods and hire the functions. But more interestingly is not about where she needs to get back to, but maybe when, because she saw that there is a sense in traveling back to the point when things started to get weird at the time, and maybe she would be able to help to stop those things and actually see what's happening at that point in this world at that time. So to be continued, we'll follow next Alice adventures in the future. Thank you for attention. I hope it was useful and interesting. My contact info is here. I have Twitter, GitHub, LinkedIn, and SpeakerDeck. On SpeakerDeck, I'm going to share my slides so we can look through them. I'll also share it in Twitter as well. And also you can find in SpeakerDeck all of the slides from the previous talks, so you can look through them or find recordings of specific talks you're interested in on YouTube. So thank you for attention.